Carl Friedrich Gauss, born into a humble family in Brunswick, Germany, on April 30th, 1777, displayed exceptional intellectual abilities from a very young age. By the tender age of 3, he was already capable of spotting and correcting his father's arithmetic errors, a feat that astounded family and friends. His early command of numbers amazed neighbors and teachers alike. Legend tells of a schoolboy Gauss who, in a matter of seconds, summed integers from 1 to 100. He devised a formula that mathematicians would later formalize as the sum of an arithmetic series, showcasing his remarkable insight. Recognizing the young prodigy's potential, a local duke generously sponsored his education. Gauss attended the Collegium Carolinum in Brunswick, where he received a robust education in mathematics, physics, and classical languages. His uncanny ability to discern patterns and connections enabled him to solve problems that confounded older students and even his instructors. During his teenage years, Gauss embarked on serious mathematical endeavors. At just 15, he independently proved the fundamental theorem of algebra, a stunning achievement that immediately established him as one of the most promising mathematicians of his generation. He also began exploring number theory, a field that would largely define his illustrious career. Gauss's intellectual curiosity was not confined to mathematics. He exhibited a deep interest in astronomy, physics, and mechanics, frequently conducting experiments and making calculations that far exceeded the expectations of someone his age. His meticulous nature and insatiable thirst for knowledge were truly unmatched. At 17, Gauss enrolled at the University of Göttingen, one of Germany's premier universities. There, he studied under esteemed scholars in mathematics and astronomy, and quickly became known for his extraordinary insight and originality. During this period, he started working on Disquisitiones Arithmeticae, a groundbreaking treatise on number theory that would solidify his reputation as the prince of mathematicians. In these early works, Gauss demonstrated a unique ability to combine rigorous proofs with elegant simplicity, yielding results that would profoundly influence generations of mathematicians. Despite his brilliance, the young Gauss remained humble and intensely private, often spending countless hours refining calculations and contemplating the beauty of mathematics in solitude. Friends and mentors admired his unwavering dedication, recognizing that his talents were destined to revolutionize the field forever. By his early 20s, Gauss had already made contributions that many established mathematicians would take years to achieve. He explored modular arithmetic, prime number theory, and geometric constructions, laying the foundation for future discoveries in both mathematics and science. He also developed a keen interest in astronomy, calculating the orbit of the asteroid series with unprecedented precision, a feat that astounded the scientific community worldwide. Gauss's early life was characterized by intense intellectual curiosity, focused dedication, and early recognition of his genius. He had proven himself to be not just a prodigy, but a profound thinker who would shape the future of mathematics and science. His achievements by the age of 22 were extraordinary, but Gauss's remarkable journey was only just beginning. From the quiet streets of Brunswick to the esteemed halls of Göttingen, the young mathematician had already made an indelible mark that would echo through the centuries. He stood on the cusp of a lifetime of discovery, destined to become one of the most influential scientists and mathematicians in history. By the turn of the century, Carl Friedrich Gauss had irrefutably established himself as a prodigious talent. Yet the young mathematician recognized that talent alone was insufficient to forge a lasting legacy. It demanded relentless work, unwavering curiosity, and a clear vision. In 1799, at the age of 22, Gauss completed his doctorate at the University of Helmstedt, presenting a groundbreaking dissertation on the fundamental theorem of algebra. His proof not only demonstrated technical mastery, but also showcased an elegance of reasoning that captured the attention of leading mathematicians throughout Europe. During these formative years, Gauss immersed himself deeply in number theory, pursuing questions that had captivated him since his adolescence. He developed innovative methods for working with prime numbers, modular arithmetic, and congruences, formalizing concepts that would become pivotal to the field. This work culminated in the early drafts of Disquisitiones Arithmeticae, a work that would eventually redefine mathematical rigor and precision. Gauss's intellectual appetite extended far beyond the realm of pure mathematics. He held a profound interest in astronomy, viewing it as a vital bridge between abstract theory and empirical observation. In 1801, the asteroid series was discovered, but its precise orbit remained uncertain. Gauss applied his mathematical genius to accurately predict its orbit, enabling astronomers to relocate it. A remarkable feat that earned him international acclaim and solidified his reputation as a master of both theoretical and applied science. Around the same time, Gauss made significant contributions to the field of geometry. He explored non-Euclidean concepts, investigating the properties of curved surfaces long before they gained widespread acceptance in mathematics. His work on geodesy, the science of measuring the Earth's shape, demonstrated his remarkable ability to apply abstract mathematics to real-world problems. Gauss also collaborated with prominent scientists and astronomers, engaging in insightful correspondence that revealed his meticulous thought process and relentless pursuit of accuracy. He insisted on the utmost precision in calculation, emphasizing that even seemingly small errors could undermine scientific conclusions. Between 1807 and 1815, Gauss embarked on several major projects simultaneously, showcasing his remarkable ability to juggle multiple complex tasks. He refined methods for least squares estimation, a statistical approach that would become fundamental in data analysis and prediction. He also investigated magnetism, mapping the Earth's magnetic field and laying the foundation for future research in geomagnetism. Concurrently, he continued his groundbreaking work on number theory, publishing significant results on quadratic forms and establishing the foundation for modular arithmetic structures. Gauss possessed a mind that was perpetually active, seamlessly transitioning between pure theory and practical applications. While many mathematicians specialize in a single domain, he bridged multiple fields, demonstrating a versatility and depth that would define his career. During this period, Gauss also experienced personal growth and faced considerable challenges. He married Johanna Osthoff in 1805, and together they navigated the demands of family life alongside Gauss's intensive work. While balancing personal responsibilities, he continued to produce groundbreaking research, often working late into the night. Fueled by his insatiable curiosity and perfectionism, his work began to attract formal recognition. He was appointed professor of astronomy at the University of Göttingen, where he would spend the majority of his career. This esteemed position allowed him to combine teaching, research, and practical observation, influencing both students and the broader scientific community. By 1815, Gauss had firmly established himself as one of the most brilliant and versatile mathematicians of his time. His work in number theory, algebra, geometry, and astronomy demonstrated a rare combination of abstract insight and practical skill. He also began to mentor the next generation of scholars, imparting not only knowledge but also a methodical approach to inquiry, emphasizing precision, rigor, and intellectual integrity. Gauss's formative years exemplify the emergence of a mind destined to shape both science and mathematics. From a precocious child in Brunswick to a respected academic and astronomer, he had laid a foundation for a lifetime of groundbreaking discovery. These years would define the trajectory of his career, setting the stage for his future contributions in diverse fields ranging from magnetism to statistics and from geometry to physics. The legacy of these years is undeniable. Gauss was not only exceptionally gifted but also remarkably diligent, deeply curious, and consistently innovative. He demonstrated to the world that intellectual genius is amplified by unwavering discipline and dedication. As he moved into his 30s, the world of mathematics and science eagerly awaited his next breakthroughs, discoveries that would ultimately earn him the well-deserved title of Prince of Mathematicians. By the mid-1810s, Carl Friedrich Gauss had already achieved widespread recognition as a prodigious mathematician and astronomer. However, he was far from content to rest on his laurels. The ensuing years would see him apply his formidable intellect across a multitude of disciplines, leaving indelible marks in mathematics, physics, and geodesy. Gauss's work in astronomy during this period was particularly noteworthy. Serving as the official astronomer at the University of Göttingen, he continued to refine calculations for the orbits of planets and asteroids. His method of least squares, initially developed to predict the orbit of Ceres, evolved into a fundamental statistical tool widely adopted in both astronomy and general data analysis. Gauss understood that achieving precision in observation required equally precise mathematics, effectively bridging the gap between abstract theory and practical application. One of his most significant accomplishments during these years was in the field of geodesy, the science of accurately measuring the Earth's shape and dimensions. He collaborated on a comprehensive survey of the Kingdom of Hanover, applying advanced mathematical techniques to map the terrain with unprecedented accuracy. Gauss introduced the concept of Gaussian curvature, seamlessly linking mathematics and geometry to the real world. His pioneering work laid the foundations for modern differential geometry and profoundly influenced generations of scientists and engineers. In addition to these practical applications, Gauss's insatiable curiosity extended to the realm of pure mathematics. He published key results in number theory, notably on quadratic reciprocity and modular arithmetic, significantly enhancing the field's structure and rigor. Disquisitiones Arithmeticae, though written earlier, now garnered widespread recognition for profound depth, inherent elegance, and enduring influence. During this period, Gauss also delved into the study of magnetism and electrical phenomena. He collaborated closely with Wilhelm Weber, a physicist and colleague, to develop the first electromagnetic telegraph and conduct thorough studies of the Earth's magnetic field. This innovative blend of theoretical and experimental work exemplified Gauss's ability to integrate mathematics with practical science, a defining characteristic of his illustrious career. Gauss's intellectual versatility was truly unparalleled. He moved effortlessly between abstract algebra, geometry, celestial mechanics, and experimental physics. Few individuals could match his remarkable ability to discern connections across disparate disciplines, making him a true pioneer of interdisciplinary science. Despite his growing fame, Gauss remained reserved and intensely methodical. He rarely sought public attention, preferring the quietude of scholarly study and insightful correspondence with fellow scientists. His letters provide a fascinating glimpse into a mind constantly evaluating precision, logic, and clarity. He firmly believed that scientific progress depended on both meticulous observation and rigorous reasoning, a principle he steadfastly applied to every project he undertook. In his personal life, Gauss experienced both moments of profound joy and deep sorrow. His first wife, Johanna, tragically passed away in 1809, leaving him to raise their children, while simultaneously maintaining his prodigious scholarly output. He later married Minna Waldeck, finding companionship and stability as he continued his demanding work. The period from 1816 to 1830 also saw Gauss make significant contributions to statistics and probability theory. He developed the Gaussian distribution, also known as a normal curve, which remains a cornerstone of data analysis, physics, and the social sciences. This groundbreaking work was inspired by his keen interest in understanding and mitigating errors in astronomical observations, demonstrating yet again how real-world problems can drive theoretical breakthroughs. Gauss's achievements during these years solidified his reputation as the most versatile mathematician of his generation. He demonstrated that mastery of multiple fields, ranging from pure theory to applied science, could indeed coexist within a single extraordinary mind. Students, colleagues, and contemporaries alike admired not only his exceptional intellect, but also his methodical, ethical, and profoundly curious approach to understanding the world. By 1830, Gauss had become an internationally renowned figure in science and mathematics. His influential work in astronomy, geodesy, number theory, and physics had already shaped research initiatives across Europe. He had established new, exacting standards for precision, rigor, and intellectual integrity, establishing methods and concepts that remain foundational to modern science. These years represent the pinnacle of Gauss's interdisciplinary contributions, a period when abstract theory met keen observation, pure mathematics met practical physics, and visionary ideas met real-world applications. From predicting the intricate orbits of celestial bodies to meticulously mapping the Earth's surface, from exploring the enigmatic properties of prime numbers to unraveling the mysteries of magnetism, Gauss's genius was both wide-ranging and deeply influential. The legacy of this period is unmistakable. Carl Friedrich Gauss was not simply a mathematician or an astronomer. He was a true visionary who seamlessly integrated disciplines, seeking truth in every corner of human knowledge. By the end of this era, the Prince of Mathematicians had secured his place as one of the greatest scientific minds in history, inspiring generations to come. By the early 1830s, Carl Friedrich Gauss had firmly established himself as a towering figure in both mathematics and astronomy. Yet, with the restless intellectual curiosity that characterized his entire life, Gauss sought new frontiers, turning his attention towards physics, geomagnetism, and practical applications of mathematics. During this transformative period, Gauss collaborated extensively with Wilhelm Weber, a physicist and colleague at Göttingen. Together, they developed groundbreaking early experiments in electromagnetism, constructing innovative devices to measure and transmit electrical signals. Their collaboration laid the groundwork for the first electromagnetic telegraph, a remarkable achievement realized decades before practical telegraph networks became commonplace. Gauss's work on geomagnetism emerged as one of the defining pursuits of his later years. He spearheaded the establishment of the first global magnetic observatory and, in close collaboration with Weber, conducted systematic measurements of the Earth's magnetic field. To quantify these complex observations, Gauss developed sophisticated mathematical methods for modeling magnetic fields, including the innovative use of spherical harmonics. These methods allowed for precise mapping of magnetic forces across the globe. This pioneering work was foundational for both geophysics and navigation, demonstrating Gauss's extraordinary ability to translate abstract mathematical concepts into tools of tangible, real-world importance. In addition to his groundbreaking work in geomagnetism, Gauss continued his meticulous studies in number theory, refining results from his earlier research and exploring previously unsolved problems. He delved into the complexities of higher arithmetic, quadratic forms, and complex modular systems, producing research that would profoundly influence future generations of mathematicians. Even in his later years, he maintained a meticulous attention to detail, emphasizing rigorous proof, impeccable logic, and unwavering clarity above all else. One of Gauss's notable achievements during this period was in the realm of physics, particularly in advancing the understanding of electrical phenomena. He applied mathematical rigor to the interpretation of experimental results, formulating precise laws to describe the interactions between electrical currents and magnetic fields. These insightful studies prefigured much of modern electromagnetism, inspiring later scientists such as Faraday and Maxwell. Gauss exemplified a rare and invaluable combination of abstract reasoning and empirical validation, using mathematics as both a precise lens and a powerful tool to explore the intricate workings of the natural world. Despite his ever-growing fame and widespread recognition, Gauss remained remarkably reserved and intensely private. He rarely sought honors or public accolades, focusing instead on his dedicated research and the mentoring of his students. His home and his observatory became vibrant centers of quiet intellectual activity, where the principles of precision, unwavering curiosity, and unwavering dedication were cultivated daily. His personal life during this period was marked by both stability and profound loss. After the untimely deaths of his first wife, Johanna, and his second wife, Minna, Gauss continued to devote himself wholeheartedly to his family, his students, and his relentless pursuit of groundbreaking research. He navigated these personal hardships with the same extraordinary discipline and resilience that characterized his academic pursuits, exemplifying a life where exceptional intellect and unwavering character were deeply intertwined. From 1831 to 1850, Gauss also maintained an active and insightful correspondence with leading scientists across Europe, generously sharing his innovative ideas and thoughtfully reviewing contemporary research. His expert opinions were highly respected and eagerly sought after, influencing developments in mathematics, physics, and astronomy. He consistently encouraged collaboration and rigorous verification, leaving a lasting legacy of scientific integrity and methodological excellence. By the mid-19th century, Gauss had achieved a remarkable breadth and depth of knowledge across multiple fields. He had transformed astronomy, number theory, geometry, electromagnetism, and geophysics, making permanent and lasting contributions to each. His unparalleled ability to integrate theoretical insight with practical observation continued to earn him widespread recognition among his peers. These years also solidified Gauss's profound influence as an educator and mentor. He guided numerous students, imparting not only vast knowledge but also a rigorous approach to scientific inquiry, emphasizing clarity, precision, and ethical standards. Through his dedicated teaching, extensive correspondence, and influential publications, Gauss's innovative methods and groundbreaking discoveries would continue to shape generations of scientists long after his own passing. As Gauss approached the end of his illustrious life, his work reflected a remarkable synthesis of his lifelong pursuits. He seamlessly combined mathematical theory, precise astronomical observation, careful geophysical measurement, and insightful experimental physics into a coherent vision of scientific understanding. Gauss demonstrated that intellectual brilliance is most powerful when applied systematically, ethically, and across multiple domains of inquiry. His later years cemented his enduring legacy as not merely a mathematician, but as a visionary scientist, a profound thinker, and a true innovator whose contributions continue to underpin modern science. By 1850, Carl Friedrich Gauss had become an enduring symbol of rigorous intellect, interdisciplinary mastery, and the relentless pursuit of knowledge, embodying the highest ideals of both Enlightenment and modern scientific inquiry. As the 1850s dawned, Carl Friedrich Gauss entered the final chapter in an extraordinary life, a life brimming with brilliance, relentless inquiry, and profound discovery. Even in his later years, his intellectual acuity remained remarkably sharp, allowing him to continue exploring complex questions across the diverse fields of mathematics, physics, astronomy, and geophysics. While the advancing years brought some inevitable physical limitations, they did nothing to diminish the fundamental clarity, unwavering rigor, and enduring creativity that had defined his life's work. Gauss continued to supervise and thoughtfully guide his students at the University of Göttingen, wholeheartedly dedicating himself to mentoring the next generation of mathematicians and scientists. He steadfastly emphasized the same core principles that had guided his own extraordinary life: unwavering precision, meticulous and careful reasoning, and an unwavering commitment to intellectual honesty. Many of his students would go on to make significant and lasting contributions to their respective fields, carrying forward the methods and insights of the master mathematician. During these later years, Gauss maintained an active and insightful correspondence with scientific colleagues across Europe. He generously offered his expert advice, meticulously reviewed manuscripts, and contributed insightful perspectives that advanced the understanding of mathematics, astronomy, and physics. His letters provide a remarkable glimpse into a mind characterized by both intense intellectual curiosity, genuine humility, and meticulous attention to detail, reflecting a lifelong commitment to the relentless pursuit of truth. Even as he faced profound personal losses, including the deaths of close and beloved family members, Gauss steadfastly maintained his demanding work ethic and unwavering intellectual curiosity. He continued to conduct experiments in geomagnetism, meticulously refining measurements of the Earth's magnetic field, and publishing innovative new methods for data analysis. His unwavering contributions during these final years ensured that the solid foundations he had built in both mathematics and physics would endure far beyond his own lifetime. One of Gauss's notable final achievements was a further development of sophisticated mathematical and statistical methods, particularly in relation to addressing errors and making precise observations in both astronomy and physics. He refined the Gaussian distribution, further demonstrating its practical utility in meticulously analyzing deviations and accurately predicting outcomes. This remarkable work not only strengthened the precision of astronomical calculations, but also laid the groundwork for modern probability theory, statistics, and advanced scientific measurement. In addition, Gauss continued his relentless theoretical explorations in number theory, including delving into complex questions about prime numbers, quadratic forms, and modular arithmetic. Although some of these profound ideas would only be fully appreciated in the years following his death, they significantly contributed to his enduring reputation as a mathematician whose unparalleled influence transcended his own era. Gauss also remained actively engaged in astronomical research, collaborated with colleagues to carefully observe celestial phenomena and meticulously refine complex models of planetary motion. His groundbreaking early work in accurately predicting the orbit of Ceres had already firmly established his impeccable reputation, and he continued to advance methods of precision observation and sophisticated mathematical modeling. Gauss demonstrated that a truly dedicated scientific mind never stops asking insightful questions, even after decades of groundbreaking achievement. Despite his widespread fame and well-deserved accolades, Gauss remained remarkably humble and intensely private, consistently avoiding the limelight while steadfastly focusing on his demanding research and dedicated teaching. He deeply valued accuracy, intellectual rigor, and methodical study above any form of personal recognition. This unwavering dedication to intellectual integrity ensured that his groundbreaking work remained trusted, highly respected, and deeply influential throughout Europe and beyond. As the years passed, Gauss's physical health began to gradually decline, yet his intellectual vitality persisted undiminished. He continued his demanding writing, complex calculations, and dedicated mentoring until his final days, driven by a relentless intellectual curiosity and a deep sense of responsibility to the advancement of science. By 1855, Carl Friedrich Gauss had created an extraordinary legacy unmatched in both its breadth and profound depth, encompassing the diverse fields of mathematics, physics, astronomy, and geophysics. Gauss passed away peacefully in Göttingen on February 23, 1855, leaving behind an unparalleled body of work that would continue to shape generations of scientists and mathematicians. His groundbreaking contributions laid the essential foundations for fields as diverse as number theory, geometry, statistics, electromagnetism, geodesy, and astronomy, profoundly influencing thinkers from Faraday and Maxwell to contemporary mathematicians and physicists. The enduring legacy of Gauss lies not merely in specific formulas, theorems, or scientific instruments, but in the fundamental principles he so deeply embodied: meticulous and rigorous reasoning, unwavering intellectual integrity, and a deeply holistic approach to pursuit of knowledge. He brilliantly demonstrated how abstract theoretical thought and practical real-world application could powerfully complement each other, achieving a rare level of profound insight seldom seen throughout history. Today, Carl Friedrich Gauss is universally remembered and celebrated as the Prince of Mathematicians, a well-deserved title that accurately reflects not only his extraordinary genius, but also his profound and lasting influence on the world of science. His groundbreaking work continues to guide cutting-edge research, inspire unparalleled innovation, and exemplify the extraordinary power of human curiosity and intellect. Carl Friedrich Gauss's remarkable life, spanning from 1777 to 1855, stands as an enduring testament to the extraordinary heights of human intellect and unwavering perseverance. Through unwavering dedication, rigorous discipline, and a relentless pursuit of profound knowledge, he transformed our fundamental understanding of the world and set an unmatched standard for scientific excellence that remains a guiding light to this very day.